This is the third video of the three-part series on pipe and tube wall thickness standards. You may recall the three commonly used standards mentioned in the previous videos. In this video, we'll focus on the standard dimension ratio system. This wall thickness system is used primarily for plastic pipe and tubing. So plastic pipe and tubing, wall thickness systems. Well, let's start with a quick refresher on plastic sizing. Remember, you're going to find plastics that are sized to both the IPS system as well as the copper tube size system. And likewise, plastic wall thicknesses use more than one system. For starters, we've already seen some examples of plastic pipe which was sized to the IPS system, which used the same steel pipe schedule system to rate the wall thickness. Here are a couple of examples of PVC and ABS, which when compared to their steel counterpart, you can see that the wall thickness is pretty much an exact match. So everything that we learned on our IPT tables in the first video related to wall thickness for steel pipe would apply to these plastic products. Don't assume that all PVC pipe uses the pipe schedule system. Quite the contrary. As a matter of fact, PVC, as well as most other plastics, use the standard dimension ratio system. As you can see when you look at some of these examples of plastic pipe and tube, they are stamped with SDR and a number. Others may just say DR and the number. Look closely at this piece of half-inch CTS PEX tubing. You see it has the same outside diameter as half-inch CTS copper tube, but the wall thickness for the PEX needs to be much thicker than the copper tube to get the necessary pressure rating. So, SDR ratings. It's actually a pretty straightforward system. SDR is the ratio of the outside diameter divided by the wall thickness. Or in other words, how many times does the wall thickness divide into the OD? So, did you get that? Well, let me ask you this then. Which material would have a thicker wall? The higher or lower SDR number? Right. The lower SDR number would have the heavier wall. Let's try a few examples. Here's a piece of 6-inch PVC. It's used for water mains. It's got a DR rating of 18. When we measure the outside diameter, we get 125 millimeters. Now, if we divided that by 18, comes out with just under 7. So that means that the approximate wall thickness is 7 millimeters. If we check that, we'd find it to be true. We're at 7 millimeters. How about a piece of IPS 1.25" or 32 millimeter gas pipe? It has an SDR rating of 10. The OD of this tubing is 42 millimeters. The same as 1.25" steel pipe. Now, divide that by 10, pretty simple, 4.2 millimeters. So that would indicate our wall thickness, which is in fact the case. Here's another piece of half-inch IPS PVC with an SDR rating of 21. You can see it has quite a thin wall. Hopefully you get the idea. Plastic pipe or tubing that are sized to either CTS or IPS systems, as these two were, can have their wall designed to the SDR system to get the necessary pressure rating. So, let's finish with our piece of half-inch PEX. You see, it has an SDR rating of 9. And that's the wall thickness ratio that the manufacturers have concluded is required to get the necessary pressure rating for PEX potable water supply tubing. So all sizes of PEX tubing used for potable water supply are manufactured to SDR9 wall thickness. As you can see when we look at a piece of 3/4 inch, it also has the SDR rating of 9. But because the pipe size is increased, you can also see that the wall thickness is proportionally increased to maintain the adequate pressure rating. That concludes the series on pipe and tube wall thickness standards. Remember, life is a pipe.